Hope you're having a great build so far, and thank you for joining us in the later half of the day for serverless architectures, effortless intelligent apps at extreme scale. I'm Devanshi Joshi, Senior Product Marketing Manager for Serverless on Azure. And in this session, I will be joined by Paul Yuknewicz, Ramya Oruganti, and Anthony Chu, as we take you through the power of serverless architectures, building intelligent apps with serverless functions and serverless containers in this era of AI. So in the last 1.5 years, we've seen AI be the trailblazer of transformation in all of our digital experiences every day. Now, with a show of hands for everyone in the room and with likes to react online for the digital experience, can you tell me how many of you interact with AI every day? Maybe on your phones, AI assistants, in your home to control lighting? Co-pilots? Nice. So 75% of the room is totally using AI every day. And how many of you like it? Like, doesn't it make it easy? You don't have to get off of your bed, go out, and turn off that light instead of, after having called it a night already and retired, ready to sleep. Pure joy, right? Simple pleasures. So let's see how we can bring this simple pleasure and joy to your life at work. How many of you deal with infrastructure constraints as you design and develop your applications? Quite a few, more than 50% here in the room. And do you like it, first of all? Do you like it? Do you like to deal with these constraints as you design it? Good, none in the room. Happy to have that, so you're in the right session. Let's talk about how does serverless architecture help you achieve your joy by redefining some of the ways how you build, consume, and integrate with solutions. Instantly scale back to zero, reduce your DevOps, and have that faster time to market while the pay-per-use comes into play. And the whole idea of event-driven architectures, the designing, begins with data ingestion, right? From data ingestion to processing these data, the events coming in, and then having them transform into the output of your desired outcome. So let's understand how do you revolutionize your digital infrastructure with serverless architectures. Harness its elasticity, cost effectiveness, and bring in that infusion for your emerging workloads to build new, as well as modernize your existing with AI, all while focusing on code. And for those of you sitting in the front row, you can see my shoes have GitHub on it. So all we're going to talk about today is code, code, code. All right. So the spectrum of application hosting varies from control, right, all the way to simplicity. And we have different flavors of it with VMs, container orchestrators, PaaS and serverless, as well as low code. And really, the philosophy of this application development lies with your development house, how you take it up being opinionated versus being more open with unstructured platforms. So a real-world solution encompasses all these different blocks, including and extending to AI databases, DevOps, and taking your app constructs and blocks from cloud to the edge. It's everywhere. So today, with Azure Functions and Azure Container Apps, we're diving deeper with serverless on Azure. And now I invite Paul to take us through Azure Functions, focus on code, and let the platform do the rest.
All right, thank you. Thanks so much, Devanshi. Hey, everybody, thanks for coming. I'm Paul. We'll switch over here. All right, so with Azure Functions, we set out to build a platform that was completely optimized for event-driven. And we did that in a few different ways. I think one of my personal favorites is that we have a programming model for event-driven. So whether you're working with message brokers like Service Bus or event streams like event hubs, or even treating your storage uploads as events, Azure Functions is completely optimized for that with our specialized SDKs that we call triggers and bindings. Also, we have the compute substrate that goes with the programming model that really makes this run at incredible scale. I'm going to spend a bunch of time on that in a bit. And some other things that are really special, I think we put a lot of effort into the developer experience to make sure that works from end to end. Right down to the runtime and tools can run everywhere. They can run in our serverless offerings. They can run an app service. As Ramya will show you, they run in container apps. They can run on VMs. They run in ordinary containers. They even run on your local machine. So you get, from end to end, you get that developer experience. Also, you can use the language that makes you happy. You know, C#, Java, JavaScript, Python, TypeScript, PowerShell, even more. So it works all the places with all the languages. It's pretty cool. And what we're even learning from our sophisticated customers out there, we're seeing that they're chaining together and making complete distributed applications with functions. And we have features like durable functions that came out of that that make it really easy to chain and to do fan-outs with multiple functions in a reliable way without having to do all the state management yourself. So lots of goodies, lots of special things and functions. And I'm going to keep zooming in. So there's a number of scenarios that functions can do, ranging from hosting simple server APIs, web APIs, all the way through the most advanced event-driven app situations that you can think of. You've heard a lot about AI. We're really pleased to show you some things today that'll make your life better in code, programming, and building out these intelligent applications. Also, I think functions superpower has really always been working with data. So when it comes to data ingestion at any level of scale, a little bit of data to fire hoses of data, Azure Functions is going to be there helping you with that. And now you have the data ingestion current superpowers with some newfound powers to do intelligent apps together. And it can do much, much more. But today, let's focus on the data ingestion. Let's focus on AI apps. With that, I am very pleased to announce that we are going into public preview right now with our Flex Consumption plan. You may or may not have heard about Flex Consumption. This is our reboot of the consumption offering. So when I say consumption, that means it has the billing model that you're literally just paying while the events are being processed. That's it. So with Flex Consumption, it has about 3 really big things. One, it can really scale on your terms. So you can do that burst scale, get the compute you need when you need it, and it can accelerate and give you instances and compute power very, very quickly. I'm talking about multiple instances in seconds. I'm talking about even, let's say, upwards of 1,000 instances. I've seen that happen in a minute. So really, really fast, and I think we'll keep optimizing that as time goes on. So you get the scale, and it gives you the scale out, and it gives you the scale in. The next thing, and I think this year more important than ever, we help you with your security by adding all the private networking features that you need to the consumption plan. Thank you. By the way, that room's loud over there, so feel free to be loud, a little bit raucous. I want them to know we're here. OK, awesome, thanks. And sometimes you have to beg for it. So yes, finally, we've got the private networking, we've got the VNets, and that works inbound, outbound, and we're really, really proud of that. And we're able to actually offer the networking while doing this crazy burst scale. Kind of think about that for a second. Instances are coming and going, they're joining private networks all at the same time. And talking about what Devanshi said, it's all serverless. It's in that serverless model. It's in that serverless compute. We do one more thing that I think is really kind of special in Azure with Azure Functions, and that's we give you control over concurrency. I had to learn from the team exactly what that meant, but here's my take on it. It's really about how many events can one instance handle at a time in parallel. So I'm going to show you an example. Let's say we set concurrency to 1. That means every event, every request is going to get its own instance. And that gives you maximum power, maximum horsepower per event, right? So if you really have that compute-intensive workload, you can give instances per event. It's pretty crazy. But also, we want you to have the control, and we want you to be more efficient. So once you figure out how to right-size your workload, you can set that concurrency higher. In this example, I've set the concurrency to 2. And that means each instance will now handle 2. And I think for the defaults, we will actually say, let's do 16. But you're going to need to fine-tune that and do it under some load, do it with some real traffic. And you're going to find what's right for you. And again, that gives you the control. And it's going to lead to more dollars in your pocket because you're going to be more efficient with the current compute power. So it's not always about scaling to thousands of instances. It's actually like set that concurrency. You actually might not need as many as you thought. Get that 70% utilization. All right. With that said, all along, we've been working on this journey with flex consumption with a very good partner, GitHub. And GitHub has been using flex consumption. Thank you very much for being a partner. You can see in this graph, this is really kind of neat. This shows a backlog of telemetry events. So GitHub uses flex consumption functions to ingest all of their telemetry, and then they can do analytics and processing on it. So you can see here, from the beginning of a run, there is a bit of a deep queue of telemetry. But as soon as the flex consumption started chomping away at those events, boom, it processes it. And they're actually seeing a steady state of 1.6 million messages per second. Yeah, pretty good. So anyway, just an awesome partnership making it come together. And we've been pounding on this thing so that it's ready for you. And that's why we feel we're ready to go public preview. All right, so let's do a demo, because I really like to get to code. And also Devanshi will make sure I get off the stage if I don't. So let's do that. The scenario we're going to do is a RAG scenario, so retrieval augmented generation. We're basically going to chat with our own data. And as you can see, boy, there's a lot of steps here. I'm going to have a rich client UI. I'm going to upload a bunch of documents to be processed. And remember, function superpowers, kind of event and data ingestion. And then I'm going to do a lot of the RAG steps. I'm going to embed the data, turn them into vectors. I'm going to do a semantic query, correlate. And then I can combine that with user prompts and do the vector similarity search. So that's like kind of a lot to do, a lot of machinery. I don't know if we have time to build that app. But that brings me to the next announcement. So we're very pleased to announce right now we're going full preview with a set of triggers and bindings for Azure OpenAI. Yeah. And thank you. Thank you so much. And this lets you do the RAG scenario. So there's triggers and bindings for embeddings. There's trigger and bindings for semantic search. And there's even really cool things that the team has come up with where you can do a stateful chat. And you can bring in your own assistant skills and basically extend the capabilities with your own APIs. And hold your breath. We're going to show it rather than talk about it. So I'm going to flip over to a demo. We'll make sure everything's awake here. All right, it's over. All right, so here's what we're going to do. We're going to have some fun, and we're going to build some functions that do the RAG scenario. Check this out. I just learned this from another speaker. Do you know Visual Studio Code has a Zen mode? Ooh, Zen. Look at that. Just my code. I love that. Seriously. All right, so I have a function called upload file, and this is a standard function. We've always been able to do this. We have triggers and bindings to work with files and events. In this case, I'm going to stream a set of files to my functions. And then we're going to do the next step, which is we're going to embed the content. The team cares about the scale and the parallelism here, so they actually chose to design this so that as events come in, they'll be teed up as service bus queue messages. And then those queue messages can be handled in parallel. They can be handled asynchronously. And then, this is the star of the show. We enter the new triggers and bindings. In this case, we have an embeddings binding. And what this will do is it can take a file path. It can take a URL. It can take a blob of data. And it's going to chunk it up, and it's going to embed it and turn it into the vectors that AI understands. And really, you could virtually count this as one line of code. So one line of code to add the binding, one line of code for return. That's all you have to do now to do vector embeddings. That's it. And don't worry, this is serious stuff. Like, you can choose which vector database you're using. So this is completely flexible, pluggable. Here we're showing AI search. We also support Cosmos DB, and more vector database support extensions will be coming. So that's going to evolve over time. Also, you can choose your own model. In this case, I'm using like ADA small 03. There's a wealth of models out there. So, functions won't box you in. It's just making it easy to use the programming model of the platform. All right. And then we're going to go to the next file. So we've embedded the data. It's kind of in our vector database. And to chat our own data, it's as easy as adding this semantic search input trigger. And in this case, we're watching kind of our vector database. We're working with our ChatGPT or our LLM models. And we can take a user prompt, just like this, just over the query. We'll take that user prompt, and we'll do the search for you, and we'll return the prompt. So basically, you can upload the data, embed the data, and prompt your data in 3 easy steps. And they're all decoupled, right? So you can do it in any order. You can constantly stream the data and ask, and they can independently scale, too. So it's pretty cool. It kind of works together. Now let's look at the app. I've used one of my favorite tools, and my team knows this, AZDUp. Can't stop talking about it. And by the way, this sample's available for you. We'll link to it afterwards. So I've created a resource group that's got my function, it's got monitoring, it's got RBAC and managed identity, all the good things I need. And this function just happens to be a flex consumption function. So here we go, Linux flex consumption with a default of 2 GB. And let's actually kind of like try out a set of the functions. So I have a static web app that will be our test client. We can take one piece of data, and we're going to call that upload function. All right, we're uploading it. Perfect. And then we're going to use this UI to make an API call to that ask function. So let's say, does my plan cover exams? And it's chatting only with our own data, so this isn't going to the internet, which is good. And yes, it does cover. And look, you even have a reference to the document. So it's doing the full RAG scenario. And I could even ask more specific questions, like what is the phone number if I need support? It's thinking. There we go. And I found that too. So it's pretty quick, pretty cool. And you can even do. You can use our new binding for chat, and you can do more stateful chats where you can ask follow-up questions. So you can see that you've got the APIs. It's just like one function API call away from doing the heavy lifting of these common RAG scenarios. Now let's talk about Flex for a second. I made a big deal. Flex is going to help us with that burst scale. So let's check that out a little bit. I'm going to go back here, actually for drama. You guys want some drama? Yeah, all right. I think I can do this. Let's tile. And let's do this. All right, so this is Azure Monitor, and this is the live metrics view. Resolution's a little funny. But let's send a burst. Whole bunch of documents. Upload. And we're going to pay attention here. I was at a low number of servers. Look, we just bursted up to 19, right in front of your eyes, from a low number of servers up to 19, and that's there to service your request. So what we in the team did is we set a concurrency of 1, so that means each event is going to get its own instance, again, just to create the drama, to show you how fast that thing can scale out. So you can use your imagination. I think, did people see Scott Hunter's talk yesterday? Some people, right? So he was showing he got 6,000 requests per second. That's the kind of scale he did on stage, and he did that. You can see the relationship of concurrency. It all kind of comes together. So you're going to have the power of flex consumption, ingest that data together with the ease of working with AI. It's going to be pretty sweet, we hope. Thank you. And I want to say one thing. I'm getting to stand on the shoulders of a lot of people. There's a lot of people here who built these demos, who built the features across all of serverless. If folks want to just stand up for a second, just give a nod for everybody else. Come on, don't be bashful. You worked on it, stand up. It's the team. Awesome. They've been working day and night to make sure this thing's awesome for today. All right, and with that said, We showed Flex, we showed AI, and I'd love to hand off to my colleague. Here we go. And my colleague also working on functions, but this case in Azure Container Apps. Hey, Ramya.
Hey. Thanks, Paul. Hello, everyone. I'm happy to be here. I'm Ramya Oruganti, currently working as a PM with Azure Functions. So today, you heard a lot of announcements from Paul on the function side. So let me talk about functions hosting options here. So functions can be built once and deployed to several destinations or multiple destinations, right? Like you could use App Service Plan if you need the dedicated compute and run functions along with web apps. You could use Elastic Premium Plan to get that consistent performance and no cold starts whatsoever. And the Flex Consumption Plan, you heard Paul talk about it. It's the best of best-in-class high-performance scale, concurrency, and networking capabilities. You can also run functions as open-source images on Kubernetes, AKS, or IoT edge devices. And you can run functions on Azure Container Apps. So I'm happy to announce the GA launch of Azure Container Apps, functions on Azure Container Apps, which is you can use the flexibility and the functions programming model, and you can have the flexibility to run functions along with other microservices, APIs, and container-hosted programs. And the function, and we have launched this last year in build, in preview, and if you've already tried the service, we have a bunch of exciting announcements today. And if you have not, and if you have not tried the option yet, then this is an ideal option to host your functions as containers. So these functions are deployed onto a container app environment, which is fully supported and managed. And the networking and observability are managed at a container app environment level, and the apps that are deployed into this container app environment share these settings, right? So going forward, functions can be deployed into the VNet-enabled container app environments as such. The environment also consists of Dapper, which helps to weave in those microservices and provides you those best practices of distributed programming model and resiliency and security. So in this hosting option, you can use triggers and bindings in the language of your choice. You can connect to various Microsoft Entra ID enabled services such as Azure Storage or Azure Service Bus, right, using the managed identity capability. So functions on container apps going forward supports managed identity, both system and user assigned managed identity as such. And you could use your favorite local tooling as well as CI/CD tooling like GitHub Actions or Azure Pipeline Tasks to deploy your function apps on container apps environment as such. And you could also test your function apps with the seamless integration with Azure Load Testing, which is available in Azure Portal today, specifically the HTTP function apps, where you can learn about the performance throughput during high load or peak load times for your HTTP function apps as such. So go check it out. And from a scaling standpoint, functions can scale to 0 and all the way to n number of tons of containers based on the events. And this is possible using Kera. You need not specifically configure the scaled objects like you do in Kubernetes. It's all platform managed. And then from a pricing standpoint, it's pay-per-use. Workload profiles are currently supported, which comes with consumption plan and dedicated plan. And you have a vast variety of memory and CPU options and combinations that you could choose as well. And going forward, you can also choose to deploy functions on GPU compute that comes with this dedicated workload profiles for scenarios such as AI, LLM trainings, or video processing, transcript processing, or audio processing, and so on and so forth. So as you can see, the hosting options are being available, and you could choose as per your requirements and leverage your resources very efficiently and optimally. I'm happy to share the story of Paychex, who's a leading firm in human capital management, and their flagship product, Paychex Flex Time Workforce Management Solution. So it's a pretty popular one. It's used for time and attendance, scheduling, and HR functions. The platform the application is used by several of their customers, and the Paychex team is constantly improving it with respect to workload responsiveness, scalability, and they're in the verge of next level growth and transformation. They decided to modernize it, and the goals that they have is to move away from monolith application, make this application more real time and high scale or more scalable, and also get the benefits of operational efficiencies and be really abstracted from the infrastructure as such. So with all the requirements and analysis, they've also looked into Azure services. So they have selected Azure Functions, Container Apps, Cosmos DB, and Azure Service Bus as part of their architecture. So here is the high-level architecture where, as you can see here, the Azure Container Apps is at the core of the compute platform, which is hosting several microservices powered by Dapr. And these microservices are encapsulated by Azure Container Apps, which are exposed as endpoints, specifically handling the user-driven workflows and also persisting the data and consuming the events that are being processed as an upstream. Functions here specifically is handling the change feed processes that's coming from the Cosmos DB and the events that are coming from the service bus as such. So as you can see, it's well structured, pretty much segregated. The DB writes, updates, event-driven programs, user-driven workflows are all separated. And they've also deployed this in multi-region to kind of eliminate that single point of failures. So yeah, we're happy to be part of their transformation journey. So they've made this architecture more scalable, and hopefully this has given you an idea of how monolith applications can be transformed into microservices. All right, it's demo time. So you've seen Paul demonstrated the chat interface application. You've seen how functions were scaling to handle those upload events. So in this demo, I'm going to talk about how to extend the functionality of the chat interface by implementing certain user-specific tasks using microservices. So here we have the static web app as a front-end interface, which is the chat UI. And once the user enters a specific task to be done, the respective function app is invoked, which stores the context in the Azure storage and invokes the OpenAI API. Using the function calling capability, it invokes the assistant skills trigger, and this is powered by OpenAI extension of Azure Functions. So this skills trigger registers several tasks, which are again segregated into microservices running as functions. And one of the function app is using the Dapr extension for Azure Functions as well. So as you can see, the microservices are like well integrated seamlessly with Dapr, securely connecting and talking to each other. So let's see things in action. So here is the assistant skills trigger. It essentially, So here is the assistant skills trigger. So it has these three functions called add task and the get task and send email. So if you see here, right, so the signature of this particular function has the prompt that the user could potentially give, and the model. The model is used to kind of respond back to the user with the natural language post-processing. So we have functions that way, which does an add to-do, retrieve the to-dos, and also send an email. And now talking about Dapr here, so one of the functions is using the Dapr extension, the invoke outward binding, which so it's as you can see, it's so much abstracted. You just need to provide the app ID and the method name, and the respective function app gets invoked and processes the add to do task. So let me show you the function app here. So the same function app that Paul deployed, it's the same infrastructure and is being deployed onto to functions on container apps as well. So it's only the hosting option that is different. So this is a container app environment which is having these two function apps. So the to-do Dapper app is powered by the Dapper extension. And then this is the AI app, which has several functionalities like upload and assistant skills trigger and so on and so forth. And yes, obviously this is enabled with managed identity. And all the interactions between these functions and services are happening using the managed identity. So this is the static web app. That's the chat interface. And in the interest of time, let me copy these prompts here. So this is in the healthcare prompts where I want to explore the various services that healthcare plans have and make few plan of tasks. Right, so as you can see here, I'm really interested in this preventive care. I'm going to go ahead and explore some more on the dental doctors too. I want to get my dental checkup done, so I'm going to create a bunch of tasks here, and then probably after exploring, I want to make an appointment and also make sure have my health card ready as well. And finally, I just want to look at the list of tasks that got created. And once I'm fine with the list of tasks, I'm going to prompt to send an email. So there you go. So the task that I've prompted has been consolidated into the list. And then the send email function has been invoked. So here, if you can see, right, so as I've prompting to do a specific task, the add to do task function is invoked, right? And then when I prompted to list the tasks, the get to do is invoked. And finally, the send function when I prompted to send an email. So let me go to my email, and if you can see here, so the list of tasks have been sent as an email to my function. And here is the app map view of how the function app is interacting with other microservices, the Dapper app and the storage and the AI models and the communication service to send an email. So that's about it. Hopefully you got an idea about how to deploy these microservices on container apps environment. You've seen how monolith applications can be transformed, and functions provides various hosting options, so you could deploy as per your needs. So thank you so much. Over to you.
Okay, thank you, Ramya. Okay, I figured out the button. Yeah. Running short on time, we're going to breeze through something so that you see more of code than me talking to slides. Okay, so Ramya already covered what Azure Container Apps does, the environment does. It's a serverless containers platform for you to develop your serverless containers. And you have event-driven scale, instant scalability, scaling back to zero, and you develop it for a variety of use cases, microservices, AI apps, backends, web apps. And the platform is equipped enough to support all your intelligent app needs with apps, jobs, and add-ons, including vector databases like Quadrant, Milvus, and Weaviate, all powered in the serverless compute platform. By the way, if you didn't know, you didn't really need to know containers or Docker files to be able to build your container apps on Azure Container Apps. And let's have Anthony go through with us on a demo.
All right, thanks, Devanshi. So I'm going to go super fast here. So so as Devanshi said, we have everything you need in container apps to host your intelligent apps. So I'm going to walk through the architecture of the app we're going to go through, and then we're going to quickly go through it. So we're going to start off with an LLM, just like all the other demos. We're going to use Azure OpenAI. And then everything else we're going to host in Azure Container Apps environment. And we're going to have a web app. So we're going to use LangChain or semantic kernel in that, and that's going to talk to our LLM, as well as a Quadrant database that's running as a Container Apps add-on. And we also have a job that is basically taking files of PDFs from an Azure file share, and then chunking them up and calculating the embeddings, and then storing them in the vector database. And we're going to run that on a schedule. All right, let's go into the demo. Buttons. All right, okay, so this is my Azure Container Apps environment. So if I go into services here, I can see my quadrant database. And over here, we can see my job as well as my front-end app. Things are going fast. OK. So I've clicked on the app's URL, and I've opened it. So I'm just going to quickly ask it a question. So like, what does the VP of sales do? And it's going to go and talk to Quadrant and then basically get the result and return it back. And let's take a look at the code for it. So this is a pretty simple LangChain application. And it's using Azure OpenAI, as you can see here. And I am using a retriever tool. So the retriever tool knows how to talk to Quadrant and run some queries and pull back some data, some documents from it. And we're giving this tool to my LangChain agent. And then the agent's going to know when to use this tool when it gets asked a question that requires searching through some documents. And it's going to use the tool to basically pull back that data and get the answer. You'll also notice here, though, that I have a second tool that I'm giving this AI agent, and it's a Python REPL tool. So this is a built-in Python REPL tool that LangChain offers. And basically, our agent can use it to do things that LLMs have trouble with, things like math, certain types of reasoning, and maybe even file processing. So let's go ahead and run this app and see it in action. Here we go. I'm just going to go ahead and refresh it. So I can ask it a simple like math question. What is some large number multiplied by some other large number? And if it's doing the right thing, it's going to go and write some Python code, execute it, and come back with a response. And we can actually take a look at its steps here. And it's actually saying, hey, I need to use the Python REPL for this, and then basically wrote some Python code and executed it. We can even do something more complicated. I have this little paperclip here. If I click that, I can upload a CSV of customer data. And then I can ask the questions like, who are the top 5 customers who bought the most stuff? And it's going to actually write some Python code to figure out the answer to that question based on what's in the CSV. Oh, no. Let me try running it again. It's supposed to work. Maybe it's not working right now. Let's see. Maybe a second try is going to do it. Please? I didn't say please. Oh, come on. Well, it doesn't matter. OK, so it's supposed to do it. I don't know why it didn't do it. And I don't have time to figure this out. But you can see that it actually wrote some Python code. I'll try to redeem myself in the next demo. So let's try to ask another question. So what if I ask, run Python code to print out a file, the contents of a file named .env. So hopefully it'll do what I think it will. So basically, this is obviously not something you want to happen in a production application. It actually dumped out a bunch of stuff. If you see your password up there right now, it's probably time to use a password manager. But yeah, anyway, so that's not what you want to happen. So let's talk about what we need to run a code interpreter that's basically running LLM-generated code in production. We need security, as you can see. So basically, every conversation should be running the code in its own sandbox, so it's not able to affect other conversations or the app itself. We need high performance. We want these things to run really fast. You don't want to wait even seconds or minutes for it. We need lifecycle management so that because we're going to have lots of these sandboxes around, we need to be able to create them and destroy them. And we want scalability. So we want to be able to run thousands of sandboxes for each of our conversations. And these are the resources that we have in Container Apps today. And today we're announcing a new resource type in Azure Container Apps called Dynamic Sessions that allows you. It allows you to run isolated sandboxes for executing untrusted code at scale. So just quickly about how dynamic sessions addresses all these issues. So everything is run inside of its own Hyper-V isolated boundary. And you can run code in milliseconds. So if you don't have a session already, it's going to basically allocate you one and run the code within milliseconds. And it will automatically delete sessions once they're idle, so you don't have to worry about any of that. And then it's super scalable, because we're already using it internally in some Microsoft products. So we're running like millions of sessions a day. There's going to be two modes for sessions. What you're going to see here is the code interpreter. So it's built in. You don't have to know any containers to use it. And it comes with a bunch of built-in Python libraries already installed. So pretty much anything that you think that you need is probably already there. And it uses consumption pricing at 3 cents per session hour. And if you need to run your own code interpreter, maybe for another language, or do something totally different, like maybe run some kind of a cloud-based IDE service, for example, you can actually do that with a custom container. All right, back to my demo. OK, so back in my app here, let's take a look at how we can use this in our LangChain app. So I'm going to go ahead and change this to Python REPL tool to a sessions Python REPL tool. And then it takes one parameter, which is the pool management endpoint, and I save it. And that's all I need to do to now change this to run my code that's generated by LLMs in a dynamic session. And we have integrations for things like semantic kernel and Llama index and more to come. And actually, there's a session right after this upstairs for semantic kernel where they're actually going to show some pretty cool demos, including like controlling lights and stuff with dynamic sessions. So check that out if you're going to stick around. All right, so I'm just going to quickly go back to my app, run it. I'm just going to run this malicious input here. And what you should see is that it should no longer do that, hopefully. There we go. It says it's not able to access the contents anymore. And we're still able to upload a CSV and process it. Who are the happiest customers in California? So it's actually going to go through, hopefully, and figure out who's got the highest satisfaction rating and give me the results. I know it's going to work this time. So what it did is actually, it took one more step, which is it actually uploaded the file to the session first, and now the code has access to it, and it's able to churn through it. And if we actually click through these steps, you can see that it actually pulled in pandas and used pandas to look at the first few rows of the CSV file to figure out the shape. And then it wrote the proper query to actually filter by state and the satisfaction score. All right. I know I'm about to be pulled off the stage, but I will refuse. So I talked about custom containers. So I'll show you a really quick sample here. So you can use custom containers if you want to run, say, a .NET code interpreter. Or you can do something totally different. So here I have an example of like a web terminal. I don't want to call it Cloud Shell, but so like here, if I wanted to create a new session called Anthony, I click that. This is how quick it was to allocate me a session and basically give me a terminal to it. And then I can switch over to another one, maybe Devanshi, change that. And now Devanshi has their own session, right? So you can actually build out some pretty cool platform that execute untrusted code really easily with Azure Container Apps dynamic sessions. Back to you, Devanshi.
One. All right. Thank you, Anthony. All right. So, OK. Something happened. I don't know what happened. There we go. OK. So dynamic sessions in Azure Container Apps is now available in public preview. Read about it in the blog. Try the sample with LangChain, Llama index, and semantic kernel. And let's wrap up with serverless in Azure landscape. You integrate with the economy of APIs that exist outside, ingest data, process data, build out your analytics for your code, as well as build intelligent apps right alongside while deploying with Azure App Service, Azure Kubernetes Service, and integrating with third-party APIs as well. Process your events and data wherever you are on the go. This brings us to the end of the session. If you want to double-click on some of the cool things that were announced today, check these blogs out. And if you're around, don't forget to check out the labs tomorrow. They are the last ones, and they've been a full pack house, Lab 310 and Lab 311. Thank you for having us today, and have a great rest of the build. Thank you.